Where does energy come from and where does it go when things stop moving? Energy comes from various sources, including sun, food, fuel, and electricity. When an object stops moving, the energy does not disappear. Instead, it is transferred into other forms like thermal energy or sound, or it is transferred to surrounding environments.
1, 2, 3, release it.
So what just happened was the fan was turned on and the wind pushed the paper and knocked down the dominoes, which then hit the roll of tape and fell on the seesaw, then knocked down the platform and hit the cookie into the milk. Alright, so before we turn on the fan, we have high potential wind energy and low kinetic wind energy. After we turn on the fan, we have high kinetic wind energy and low potential wind energy. When the wind almost reaches the lever, we have high potential mechanical energy and low kinetic mechanical energy. Then, the lever begins to spin. There is some potential mechanical energy and some kinetic mechanical energy. After the lever is fully spun around, there is a low potential mechanical energy and high kinetic mechanical energy. When the lever is almost at the dominoes, there is a high potential gravitational energy and a low kinetic gravitational energy. After half of the dominoes have fallen, there is some potential gravitational energy and some kinetic gravitational energy. Then, when all the dominoes have fallen, there is a low potential gravitational energy and a high kinetic gravitational energy. When the roll of tape is on the table, there is a high potential gravitational energy and a low kinetic gravitational energy. Then, the roll of tape is halfway on the ground. There is some kinetic gravitational energy and some potential gravitational energy. When the roll of tape hits the ground, we have high kinetic gravitational energy and low potential gravitational energy. As soon as the roll of tape hits the ground, the seesaw has high potential mechanical energy and low kinetic mechanical energy. Just after, when the seesaw is horizontal, we have some potential mechanical energy and some kinetic mechanical energy. Then, when the seesaw is fully tilted, we have a high kinetic mechanical energy and low potential mechanical energy. As the cookie is sitting on the platform, there is high potential gravitational energy and low kinetic gravitational energy. While the cookie is falling, there is some potential gravitational energy and some kinetic gravitational energy. When the cookie is in the glass, there is low potential gravitational energy and high kinetic gravitational energy. Once the cookie is falling, there is a high potential sound energy and low kinetic sound energy. And lastly, when the cookie splashes in the milk, there is low potential sound energy and high kinetic sound energy. Throughout this whole process, we use 4 different transfers of energy. We use wind to mechanical, mechanical to gravitational, gravitational to gravitational, gravitational to mechanical, mechanical to gravitational, then lastly gravitational to sound. So in total we have wind energy, mechanical energy, gravitational energy, and sound energy. A real-life example that was related to my project was a wind turbine. Wind turbines are like giant pinwheels that turn the power of a wind into electricity. Just as pinwheel spins, you blow on it, the turbine's blades spin and turn a generator to make energy for my project. I used a fidget spinner and added paper to the blades, curving it to make a little pocket so the wind could catch and spin it like a mini turbine. You can also think of a turbine like a water wheel, using natural movement to create power. Before we end this, I would like to take a moment to explain some of the mistakes and errors that happened during this experiment. So what just happened in that video was that when we turned on the fan and it blew the little turbine, it had only reached the first domino. And I guess the other domino was quite far, so I didn't knock down the rest. What also happened in that video is that when the dominoes were all knocked down, it hit the 2 other dominoes, and they did hit the seesaw, but not hard enough to hit the little platform for the cookie to knock down into the milk. So this one took a bit longer because either the dominoes kept on missing the seesaw or it just wasn't power enough to hit the platform and knock down the cookie. So in total, this took about 5 tries to get this all together. In conclusion, I built a Rube Goldberg machine that demonstrates multiple energies transferred to dunk a cookie into milk. Wind energy was transferred into mechanical energy by the fan and wind turbine, which then became gravitational potential energy as parts were lifted. This energy continues to transfer throughout the gravitational and mechanical changes in the dominoes and seesaws, and finally changed into sound energy when the cookie hit the milk. Overall, the machine showed how energy is transferred through a system to complete a task.